Welcome to this brief presentation on the space track of the Aerospace Engineering Master Program. My name is Kevin Cowan, and I'm the track coordinator for space. Let's face it, space is a big place, and there's a lot of ground to cover. In this track, we cover a lot of it, with a focus on spaceflight. So what does this mean for you? Well, first off, we cover the full cycle of a space mission, from conceptual design to implementation and utilization. We also cover all the mission phases from launch through mission operation to end of life. And you need to be well equipped with knowledge and awareness across the spectrum because of the unique nature of working in space. The design of each mission and all of its elements is fully focused on achieving the specific objectives of each individual space mission. In this track, you work towards participating in ongoing engineering and scientific projects. You do this through developing your individual knowledge and skills, as well as applying them in context while working with others. Collaborating with others is critical in space because there is no shortage of challenges which can only be met by combining the expertise and skills of people with different backgrounds. Now, you're probably already aware that space activity is booming again, and you're fortunate to be considering a career in space right now. And the exciting thing is, space missions require us to develop and apply the very latest knowledge and techniques, linking research in science and engineering. Consider some of these challenges. Spacecraft are no longer limited to the size of a truck, but are now being reduced to the size and mass of a CubeSat, even one you can put in your pocket. This, in turn, reduces the cost and increases the return of the mission. This increasing refinement and miniaturization of a spacecraft and its systems contributes to providing low-cost access to space. These efforts extend to the design and optimization of the rocket engines and launchers themselves, including sustainable space transportation technologies, such as green propellants. Another area of great concern is the sheer number of space objects already in orbit about Earth. Recent estimates of space debris objects in orbit amount to 30,000 debris objects larger than 10 centimeters, 670,000 larger than 1 centimeter, and more than 170 million larger than 1 millimeter. The rapidly developing need for space situational awareness is undeniable for tracking and dealing with both desirable and undesirable objects, such as space debris. Further afield, also on missions with objectives well beyond Earth orbit, the employment of efficient transfer trajectories and propulsion, such as solar sailing and low-thrust technologies, brings many more missions into the realm of the feasible. And let's not forget about the mission objectives themselves. You may have considered the fact that it is difficult to run a cable into space to transfer all of our observed data back to the ground. Fortunately, our continuous advancement in terms of processing the data we gather through better computational techniques and power increases the accuracy and resolution of our results and allows us to develop new instruments and missions and extract more science and knowledge on the planets and moons at a great distance and very close to home. So what does this mean for you in the near term? Well, we've organized the space track into a number of profiles, which are more or less in line with our research areas. Let's start with space engineering. The focus here is on the vehicle itself, whether it be the launcher or the payload, the spacecraft, which carries the instruments and the subsystems necessary to support them. Your considerations range from individual subsystems, such as miniaturized propulsion, electronic or communication systems, to full satellites, as well as distributed space systems, which have multiple spacecraft cooperating to achieve specified objectives. Next, there is spacecraft dynamics, where the focus shifts to the motion of an object, usually a spacecraft, but this could also be a heavenly body or space debris, such as a fleck of paint. You learn about mission analysis and trajectory design, precise orbit determination, the motion of launch vehicles, re-entry systems, and other space objects, such as debris, under the influence of gravity, planetary atmospheres, and other forces, as well as the guidance, navigation, and control of spacecraft. And finally, we come to planetary exploration, where the focus is on the study of heavenly bodies, such as planets, moons, asteroids, and related phenomena. You learn about the structure, the environment, and the dynamics of these bodies, both above, at, and below the surface. This is done through analysis of the data gathered from in situ and remote observations, laboratory experiments, and deep space tracking. So you see that while you don't actually go to space yourself, at least not yet, you are exposed to a full spectrum of space engineering and science. And it's worth noting that not only do you develop a solid expertise in your chosen area of focus, but that you have the opportunity to apply this expertise in numerous active projects, supported by a variety of research facilities. So in addition to projects you can contribute to with our partners around the world, we have facilities right here in Delft, such as the Clean Room, where you can get involved in the integration and testing of small satellites and propulsion systems, the ground station and the rooftop laboratory for communicating with satellites and determining the orbits of space objects. To that, our advanced open-source software package for orbit estimation and propagation, networks of operational GPS receivers, the robotics labs, a pressure chamber for planetary lab experiments, a drone for simulated planetary surveys, and an optics lab for spectroscopy. I hope you've now got a good impression of just how many possibilities we have for you to explore. Indeed, your first challenge may be to narrow your field of view from among the plethora of options. Fortunately, the options are not limited to your study. SpaceTrack graduates are highly sought after and readily find a job after graduation. These range from the large international and national space agencies that you know the names of, to companies in industry, from large multinationals to numerous space startups founded by our very own recent graduates. Students with ambitions to continue research in space also pursue PhDs in Europe and beyond. And if your interests lie beyond the edge of space, rest assured that the knowledge, skills, and abilities you have developed in the SpaceTrack are highly attractive to the many employers that seek our graduates. You knew space was big before you started this video. Yet I hope I've shed some light on how many tantalizing topics exist through which you can plot a path to your career in space. If you want to discover more, I've selected a few good places to start here. Go to the repository of the university and browse through the master theses on recent space topics. Check out the courses and profiles on offer in the study guide, as well as the further SpaceTrack information on Brightspace. Good luck with your ongoing reconnaissance, and perhaps we'll see you soon in space.